Good morning to all. Myself Shazana, and today we are going to learn about the longitudes and the latitudes. But before that, let's see how does we know that the shape of the earth is sphere, or actually it is not a perfect sphere. It is geoid. Now what do you mean by geoid? We will learn about this as we proceed in this chapter. So today we are going to learn about the shape of the earth and how does we discovered and come to the conclusion of that the earth is of the shape of geoid. And then we will also talk about how the navigation was invented. At this time we use GPS and we send locations, so these type of thing we use. But in the earlier time or in the past, what happens? Does there was any technology like this? Of course not. So how does they come to the conclusion of the navigation? How does the navigation was invented? And what happens in the past instead of how does the sailors and the explorers discover interesting things like the lands? Now there was a very different and interesting ways of discovering, and we will learn about this in this chapter. So now let's start this chapter. So if you will look around you, you will see that it is a flat, right? And that's what the explorers and the thinkers think in the past. They think that the earth is a flat disk roaming around in the space. But if you will see the sky, so it seems like a dome, right? It seems like a circle which is covering the flat disk. Now let's understand, let me draw something on the board so that you can understand this more better, right? So now let's move on to the board here. So, yeah. So earlier the thinkers and the philosophers, all of them think that the earth is a flat disk in which there is a dome shaped sky, right? So they think that here this is the sky, this is the flat disk type thing. So this is the shape is actually a flat disk type thing. So the philosophers think that here is a dome shaped sky and here is a flat disk type earth, right? So they think like that the earth is like this. Not really, right? Okay, so now let's move on and now let's talk about, so here let's see how does they come to the conclusion from the flat disk and the dome shaped sky like thing to the geoid shaped earth. Now how does they discover this? There was very interesting things which happened and which led the thinkers and all the explorers, philosophers that the earth is, they need to again check that what is the shape of the earth. Now what was the things? See, first they noticed the sun and the moon. Now if you will see the shape of the sun and the moon, they are clearly circular, right? So they thought that if the sun and the moon sun and the moon are the usually seen bodies, celestial bodies, right, in the sky. So they thought that the earth should be like that. And one another thing which they had noticed is that the shadow of the earth on the moon, right? We had seen many phases of the moon, like third quarter or the first quarter or the full moon, right? And the new moon or the crescent all shapes. Right? How does this happen? This happens because the earth casts its shadow on the moon. And we will see the shadow of the earth on the moon. It is like circular. Or how can a flat disc cast its shadow, right? So that also led the philosophers and the thinkers to think that the earth is spherical. And after that, Aristotle, he said the earth is spherical. How? See. Now let me explain you with this card. So here, let's say that this is the earth. Let's imagine. So this is actually a globe. Now let's imagine that this is the earth, right? And this is the car, okay? So when we usually moves, we move like this, right? So if there is a mountain here, let's say that my hand is the mountain, okay? So when the car is moving like this, see, firstly, let me just keep this car here. Firstly, from the window of the car, if I will straightly draw with this, so you can see that the car is able to see the top of the mountain. Imagine my hand as a mountain, okay? So the car is able, the people in the car is able to see the top of the mountain. Then if they will move on till here, okay. Let me just do like this. So they can see the top, and as they move further, they can see the bottom here, and then a little, and then at this point they can see the whole mountain. So why it is happening? It is happening because of the spherical shape of the earth, right? What if the earth is like flat, like this table? Yes, so here will be the mountain, here will be the car. So when they move, they will see whole mountain, right? They will see whole mountain. It's not there that they will see the mountain top first and then the mountain, right? So these observations led the Aristotle to think that the earth is spherical. And then he proposed that the earth is spherical in shape. But was he right at all? Was the shape of the earth actually perfect sphere? No, it's not perfect sphere. Now let me tell you. Let's see this globe again. Can you see it? Is it a perfect sphere? I'm not able to see it. Right? That's because the earth is squished on the tops. Right? The earth is squished like this. Can you see this? How it is squished, and the sides, and these two sides are like bulging out, or like spreading out, right? The top is squished and the sides are just spreading out. So this shape is known as obligate spheroid, or another name of this is geoid. As I had already told you, so we can say that the shape of the earth is obligate spheroid or geoid. So I think it's clear. Now, so that's how the shape of the earth was discovered. Very interesting, right? Now, who told this, that the earth is squished and the sides are just spreading out? Newton, yeah. The final edition of Newton. Newton added that the earth is not exactly spherical. It is of the shape of obligate spheroid or geoid, which means that it is squished and the sides are spreading out. So I hope that it's clear. Now let's move on to the invention of the navigation. Now what is navigation? We all know that, right? We send our locations at this time. If someone wants to come to our home, right? If our friend or any relative wants to come to our home, so what we does? We just send them the location through with the help of the GPS at this time. But what happens? Now see, what happens in the earlier time, right? How does they navigate? And how does the sailors or the explorers discovered amazing things like this land, Iceland, right? So there is a very interesting story how was Iceland discovered. See, now I am going to tell you a story of a very interesting sailor. His name was Floki Darson, and he discovered Iceland. Now how does it happen? See, he used to carry so many black birds in his ship, and they were like crows, but they were not crows. They are known as ravens. Yes. So there were so many black colored birds known as ravens. He used to carry them in his ship. Now what happened is that when he thought that the land is around, so what does he do? He take one of the raven and release it. Then what happens is that when that bird comes back to the ship, he thought that there is no land. Why is that? That's because the bird is coming back, right? If there was a land, so what will happen? The bird will go to the land, right? So if there is just sea around it, so of course the bird is going to come to the ship back, right? So this was an interesting thing that he does. He released one bird when he thought that there was a land around him, and then if the bird returns, he get to know that there is no land. And if the bird didn't return, what happens? He take his ship into that same direction in which the bird has gone, and then he obviously found the land, right? And that's how the Iceland was discovered. Very interesting. And in earlier time, the navigation was done through the stars and also like the size of the waves and the sky patterns and so many interesting things like this. But here is a very interesting story of explorer named Christopher Columbus, and he wants to discover India, and he actually just went out to discover the India. But what happened? Very interesting thing happened at that time. So he used the compass and he used all the size of the waves and like that he used it. But what happened? He reached to the land with a a journey full of the danger. There were so many tsunamis, there were so many difficulties which he faced, and after so many difficulties he reached the land. Then he was pretty sure that it is India, but what happened after that? Now he was not at the India. Now we know that he was not at the India, but he was at the land which is so far from India. Let me show you. See, this is India. Are you able to see this? Right? This is India. Let me just rotate this globe a little bit here and here. He reached at the South America. Right? So where he reached? See, both. See, please see both. Let me zoom out a little. Zoom out. Now I think you can see this. So here, this is India. This is South America. Let me see this. So this is South America. And he reached South America. Instead of India, he reached South America. What a large distance! Oh my God. So, because we now know that the size of the waves, that here the size of the waves will be this, here the size of the waves will be smaller, here the size of the waves will be larger, and like that, this led to the Christopher Columbus to go in a wrong direction. Now, I think it's clear. So, these were the two very interesting stories of the navigation and two sailors, right? So now let's move on and now let's see how can we, let's say that, now let's take an example, okay? So let's say that your friend lives in foreign, okay? And he's coming to your home, okay? You are in India, I think so. So, what will happen? Now, are you going to send the location? Okay, yes, you can send the location also. But do you know that when the aeroplane flies, right? When the aeroplane flies, how does they reach any place? That's pretty interesting. Does they carry maps? No, of course not. They doesn't carry any maps. So how does they reach there? How does they reach to a particular place? They use the help. They take the help of the latitudes and the longitudes. Now you will say, what are these longitudes and the latitudes? Let's study this also. So here I have a globe, and here the latitudes and the longitudes are well marked if you will see it carefully. So these all the lines. Now let me tell you what are the latitudes and the longitudes. See, here is can you see these all? Right? So these lines, these blue lines. So these all are longitudes. Now, what are these longitudes? See, should we start with latitudes or longitudes? I think that we should start with the latitudes. I will tell you the reason of that after a little bit of time. But let's start with the latitudes first. So, these latitudes are, let me tell you here. Can you see this? This is a latitude, one latitude, right? So actually, what are the latitudes? The latitudes are, let me show you on the board, right? So let's move on to the board and let's see what are the latitudes. See. So here, if I will take the Earth, so the latitudes are the lines, the imaginary lines which goes like this, right? So these are the latitudes. Are you able to see these up? Yes. So these all are the latitudes, and one thing which you can notice is that here the latitudes are very small. Here it is a little larger. Longest latitude. Smaller. What is happening? See, the Earth is spherical or the obligate sphere, right? So the Earth is of the shape of obligate sphere, right? But if you will see it carefully, so what happens in a circle? The diameter is the longest one. The longest, you can say, the diameter is the longest chord, right? Like this on the Earth. The longest chord or the longest latitude is the central latitude, which divides the Earth into two halves. Northern hemisphere and southern hemisphere. Can I use northern half and southern half? Of course not, right? So, we call the half of this, see, the earth is in the shape of sphere, right? So this is known as the hemisphere, one part, and this is the another hemisphere. Northern hemisphere or the north hemisphere and the southern hemisphere, right? So I think it's clear. So now let's see this very interesting latitude which cuts the earth into two parts or two equal parts. So now let's move on to the globe here. So I'm just going to move on to the globe, but first let me show you some of the here equator, this one. Can you see this? Just have a look there. Yes. Now let's come back. Yeah. So basically that special latitude is known as equator. Yes. Now do you know very interesting thing here? That these all latitudes are parallel to each other, right? They are parallel to each other. Now how can I say that they are parallel to each other? Have a look here. See these all latitudes here which are going parallel like this and this and this. Right? Now, here, see, so the equator divides the earth into two halves, and there are so many latitudes also. How many latitudes are there? See, from the bottom, see this, the top latitude is known as North Pole, and the bottom is known as the South Pole, right? They're very interesting. So here is the North Pole, here is the South Pole. Now here is the equator. Now there are so many latitudes from here and there are so many latitudes from here. So from the equator the latitudes goes like this. The equator is considered to be a 0-degree latitude, and after this here is a 1-degree latitude, 2, 3, 4, 5, 6, 7, 8, 9, 10 until the 90-degree latitude, which is the South Pole at the bottom. And in the up, here is the 90 degree. From the equator to the North Pole there are 90 latitudes, and from the equator to the South Pole there are again 90 latitudes. So 90 plus 90, 180 latitudes in total. How interesting it is. Yeah, very nice. Now these all are the latitudes. Now we are going to learn about some very interesting latitudes, right? So there are actually 7 interesting latitudes. Don't scare with their names, they are very interesting. So now here, if you will see this globe, can you see these degrees here which are written, right? Can you see these degrees? See, this is the 90 degree, right? The North Pole. 80 degree, 70 degree, 60 degree, 50, 40, 30, 20, 10, and then 0 degree at the equator, right? Then again 10 degree, 20 degree, 30 degree, 40 degree, 50 degree, and so on till 90 degree at the South Pole. Now the interesting latitudes are actually here. Can you see this? At 23.5 degree, actually here, right? This let me just show you with the help of the marker. See, 23.5 degree here. Can you see this latitude? This latitude? What is it called? Tropic of Cancer. Can you see the name written on the globe? Tropic of Cancer, right? So this is known as the Tropic of Cancer. Now why it is very special? Why it is very special? Now I want you to find out this. There are basically the North Pole, first very special latitude, then the Tropic of Cancer, and then we have here, can you see this? Then the equator, and here we have the Tropic of Capricorn, here we have the South Pole, and two more very interesting latitudes. But right now I think that the duration of this video is going to be too long, so I'm just going to stop this video right here. So thank you for watching this video and have a cheerful day ahead, and thank you.